Hi, my name is Ali, and I'm the head of data science and driver. I got my PhD in medical image processing, so I'm coming with a background of healthcare with more than 7 years of the image processing and computer vision. And here at Driver, I'm basically heading all the data science, computer vision, and analytics effort.
Hey, I'm Rashid Galadanci. I'm the co-founder and CEO at Driver Technologies. I have a background in management consulting and then microfinance, followed by private equity and venture capital with a focus on technology and data and social impact. So when I think about how 2D data can help improve accessibility of AV technology globally, it really aligns with what we're doing here at Driver, which is all about democratizing car safety. And so when I think about, we're developing, and it's already out in the wild, been downloaded in 170 countries, a driving safety app that uses computer vision on the edge and 2D imagery that's streaming into the phone, which is a device that a lot more people have access to than have access to a brand new $100,000 vehicle. For us, the 2D images are what let us spread that safety globally at a very low cost.
But one thing to add to that fact is when we look at the AV industry, each of these companies, they have this multi-million cars with hired drivers going around and collecting data in order for them to be able to train their basic self-driving cars. What happens, if you can imagine, is the basically hired drivers, they are really conscious of they are collecting data, and it's not the standard the driving behavior of like people just driving the world. With us making that accessible, that data kind of data collection, now the AV has an unfiltered view to the real scenario.
So thanks to our collaboration with CloudFactory, we've actually received millions of hand-labeled images around driving behavior, and that's really helped us refine and improve our product. And a major kind of obvious thing that jumped out to me right off the bat was that when I looked at existing data sets, of which there were many, both free and purchasable, they were both very small, based on very limited geographies. And the cameras that were used were often very high quality ones or a very specific type of camera. And what we wanted to do was make sure that we built a model that was responsive to and expecting data that looked like dash cam data or phone data. And I think an easy way to explain it to someone who maybe is less technical is if you have a picture of a dog and it's labeled as dog and the background is like a green screen or a professional background, that's one thing. A dog crossing a road with a bicycle between you and the dog and a bunch of people walking around and New York City trash in the road is a very different thing. Yeah, so when we think about using 2D data to enhance our capabilities and move into new markets, we really take a partnership approach. So we're very excited that we're already working with basically all the leading AV companies, as well as many of the leading insurers, around how do you take a scenario that's occurred to a driver, whether that's an anonymous driver from a safety perspective, or someone who wants their insurance company to protect them after an accident and stand up for them. How do you kind of take that scene, recreate it in a 3D environment, right? Understand what the different actors were in the scene, where they were moving, what was going on, and be able to provide that in a way that can be analyzed by someone who's interested in the outcome of that accident, safety issues around that kind of scenario. And I think what's exciting to us is that really allows the best possible protection from an insurance company to a driver. B, the study of scenarios that are high risk scenarios, but in a very privacy conscious way. So you don't even need to see the imagery of that street if you can create a recreation and allow people to study what was going on in that scenario in a simulated environment. And then finally, it allows you to take people's existing technology, like an autonomous car model, and put it into a simulation environment and see how it would have performed in this what people call an edge case scenario, but actually is a scenario that happens every day. Scary accidents, scary near accidents, confusing interactions in different intersections.
I guess to just second what just Rashid said, we are looking at this kind of data collection in two different way or viewpoints. One is insurance and accident scenarios. The second side of it, as also Rashid mentioned, is on the AV industry. As I also mentioned, like they have these hired basically drivers that, as far as I can say, they never get into accident. Therefore, they don't really have any accident data. But we are collecting more than 2 million miles a month. That has a lot of accident into it. So we are recreating this environment in the kind of general simulation environment. Then when basically they place their car inside that simulation, the car can see that accident happening and can react to it. And therefore they can kind of validate if their software can properly and safely navigate around that situation. So in terms of us keep using the 2D images versus adopting LiDAR, I guess our answer is we're going to be keep using 2D images. We have these supercomputers in our pocket that are basically collecting our data all day long, 24/7. We just want to leverage what people already have. So the smartphones are so capable of doing so many things that we don't see any need to kind of introduce a new hardware. A good LiDAR that can actually properly collect data can cost a few $1,000s. That we don't want to basically do that. So that's one side of it. But when we look at basically the drivers of this market, Teslas of this world, they were able to achieve to drive the cars 100% autonomous by relying only on the camera and vision. They don't have LiDARs. But since they have a 360 view of the car by having like about 8 cameras around the car, they can easily navigate. So when we look at the different papers that are publishing into this kind of community, they're so accurate in estimating distances by having only 2 cameras that just eliminates the need to have any LiDAR. So the cameras are so good. We are in the kind of era in terms of the technology that our vision is so strong that having a LiDAR just for the purpose of distance doesn't really make any sense anymore.